We are looking at what a quadratic is and answering these questions about what a quadratic is. Um, I have the goal of giving you a definition of a quadratic function, talking about here's an answer to your question that you asked, some of those terms, tell you what a vertex is, tell you what the roots, zeros, x-intercepts, factors of quadratic are, the axis of symmetry of the quadratic, and the y-intercept. So let's do this. A quadratic function. I am almost certainly doing this the wrong way. Uh, yes, that's the one I'm supposed to be doing, not that one. Much better. Oh, oh my gosh. This is confounding. Have no idea if this is going to work, but we're doing our best. Quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c, uh, where a, b, and c are real numbers. The way I'll say that in the future is I'll just say a, b, c in the set. That means in the box, and that r means real numbers. A, b, c in the set of real numbers, with a not equal to zero. So that's what we mean, or what I mean, or what we'll mean in the class by quadratic function. Then we're going to graph just an example, label, and then actually do the do now. Why don't I use another color? Got all these colors over here. Not a bad parabola. The graph is a parabola. That's worth spelling out. And we have a bunch of points that are important on here. That's the y-intercept. Ah, when I don't leave enough room. So frustrating. That is the y-intercept. Uh, those are both x-intercepts. A little too much. Zoom out. Whoa, I went crazy. There we go. Zoom out so I can fit the word x-intercepts. This thing right here, this line right here, I can do better than that. Let's pick our vertex first of all. That point is the vertex. That is the axis of symmetry. Uh, uh, and the equation for the axis of symmetry. I'm not going to do this too much in this class where I just give you an answer. But at this particular point in time, I'm going to give this to you, and we're going to later come back and we're going to figure out why the axis of symmetry is the line x equals negative b over 2a. And we're going to figure out why this is showing over here. Can I? There's probably a way out there. Please, just out there. Maybe if I do this. What color are we on? Black. Anyone have any questions about that picture? Okay. Another important consideration, the maximum or the minimum. Does the parabola have a maximum or a minimum? The rule is if a is greater than 0, if a is positive, the parabola opens up. You're being positive. You open up and have a minimum. So we don't know the equation of this blue parabola over here, but we do know that it's opening up, right? And since it's opening up, we know A is positive. Whereas if A is less than 0, it opens down and has a maximum value. Okay. Any questions on that? I'm going to need to scroll off so you won't be able to see this. Let's scroll. Oh, I can't go any further than that. Okay, fine. We'll go over, I don't know, we'll go over here and scroll in 200%. I don't know, does this make you dizzy? It makes me dizzy. I apologize if it does make you dizzy. I like the tool, it's kind of cool, but it makes me a little dizzy. And now I forgot what the equation is. I have it right here. F of x equals negative x squared plus 2x plus 3 So what we're going to do to graph this as our first official parabola is we're going to make an xy table or an x input output x f of x table. And we're going to consider some values. Let's do negative. What points am I supposed to do on this? I like to do uh, 0, 1, and 2. I'll do 0, 1, 2, and 3. So if we put 0 in, that term's going to cancel out, that's going to cancel out, and we're going to be left with 3. So for x is 0, the output is 3. If we put 1 in, we get negative 1 plus 2 times 1 plus 3. 5 minus 1, we get 4. If we put 2 in, we get negative 4 plus 2 times 2 is 4 plus 3. And if we put 3 in, we get negative 9 plus 6 plus 3 is 0. And we can make our graph now, sketch the graph and plot the points. Go to 0, 3, 1, 2, 3. So I have a point at 0, 3. The point 1, 4, 1, 1, 2, 3, 4. And so we have a point at 1, 4. The point 2, 3, 1, 2, 2, 3. A point at 2, 3. And finally 3, 0. And we can sketch our parabola. On the sketch of the parabola, we can see several points already. We can see our y-intercept here is the point 0, 3, or just label it as 3 for our y-intercept. We can see this point here. It looks to be the highest point. How can we confirm that it's the highest point? X equals negative b over 2a. Plug in our b value. A is negative 1, B is 2, C is 3. Plug negative 2 over 2 times negative 1. That's negative 2 over negative 2, which is 1. So we see that the line x equals 1, oh, this is so fun. No, did my computer just freeze? Come on now. Oh, it doesn't want to do my fancy. The magic mirror uh, that isn't writing very well. Magic mirror. Uh, X. Whoa. We've got some serious tired computer. Just ended up with some lag. That's what happens when you switch to the rainbow colored pencil. X equals 1. Okay. Uh, and so we know that the x coordinate of this point is in fact 1. And now we need to figure out the y coordinate. Oh, but we have it. It's this point right here. So we know that the vertex is in fact 1, 4. For the x-intercepts, we happened to have a point on the x-axis, the point 3, 0. So we know that that's one of our x-intercepts. This other x-intercept, the other one, if I was to continue this line on, I'd hit somewhere. It looks like this might be 1 or 2 or 1.5 or something like that. How can I figure out the exact coordinates of that point, the left x-intercept? What can I do to figure that out? Anyone? Plug back in. Yeah, we could try some values. We could plug in 1 and plug in 2 and see if it happens to give us, sorry, -1 or -2, see if it works. Anyone have any other suggestions how we could go about doing it? I'm going to say that a hint that I want you to think about uh, is the um, axis of symmetry. What do we know because of the axis of symmetry? There we go. So that distance right there, we know this is at 1. We know this is at 3. So how far is that distance? Whoa, that's a weird 3. We know that point is at 3. So that's a distance of 2. And if we go 2 to the left of negative of 1, we get to uh, -1. So we know, even without plugging in, just based on the symmetry of the parabola, that that value right there has to be -1. Okay, we have 2 minutes left in the period. Holy potatoes, 34 chats. Uh, Look at those. Those are fun. Uh, 12 minutes. Yes, hooray. We have 10 more minutes than I thought. That means that I can actually read these chats. Uh, Turn that frown upside down, bud. I have yet to find the funny. Why you bully me? Be quiet. Oh, the hype. The F in a name stands for funny. The roast. The A in another name stands for amusing. Okay, this is definitely needs to be saved for posterity. Uh, Wait, does this make? I don't know about that. I don't like that word. IDRC, what I said isn't even funny. I'm just tired. Uh, Not really what. Never mind. The V in a name stands for vindictive. Bruh. The irony. Okay. What were we doing? Yes, go. So what we did was we counted, we looked at the x-axis as a number line, right? So we just thought of this as a number line and we just counted on it. So we knew this point was 3 and we knew this point was 1. And so we counted back 2 steps to get to 1. And since the parabola is symmetric, which means if you fold it in half, it lands on itself. If you fold it in half along this kind of rainbow line, the axis of symmetry, the side on the right should land on the side on the left. So we did 2 steps to get here. Well, it should be 2 steps to get to this point as well. And so we just count 2 down the number line from 1. You go down 1, you get to 0. 1 more, you get to -1. Does that make sense? Awesome. Uh, Let me look. I can't even remember what the other question was on this. Do now, what do these tell you about the equation? Oh, there's also, this is important on the mini lesson I wanted to talk about. Just these kind of, right now, we're going to call them synonyms. We'll eventually learn that they're not quite synonyms, but for now, calling them synonyms is more than adequate. Why can I not scroll? There we go. Uh, we're going to call uh, these guys, that 3, 0, we're going to call an x-intercept, which you're used to. We're also going to call it a root. We're going to call it a 0, which you're familiar with now from the graphing calculator. We're going to call it a something else. Can't ever think of the other one. Root zeros. Oh, a solution. And we're going to call it a factor. All of those words. And eventually we'll find that all 5 of them are slightly different. But for the purposes of what we're doing right now, we can consider those to be synonyms. We can consider those to have the same meaning. Okay, and so then the last part is, what does all this tell us? Well, it tells us something about what the parabola looks like. We can use this to find this kind of symmetry information. Um, we can look quickly at the equation, and the constant term is going to be our y-intercept. Uh, we can use a variety of tricks to get these x-intercepts. Uh, we're going to see in this unit uh, why factoring works. And when I say factoring works, many of you may have factored this to get the zeros. That correspondence might be falling into place for you. Um, and I think that's it. I think that's the answer to the part C. Uh, for the rest of the minutes that we have, 7 minutes, I'm trying to decide whether we should go on maximum or minimum y-intercept. I think we should do this other problem. Yeah, because this is important. I've set it up to confuse on purpose, and I don't want to miss out on that opportunity. So we're going to go down and we're going to do the do now second do now problem. Do now 2. And the second problem is this: 0 equals x squared minus 6x plus 3. And the question says graph the function. And when I see graph the function, I respond by saying, wait, this isn't a function. How can I graph the function when it isn't a function? What did I just hit? Who knows? There's some trick to being able to quick scroll where you want that I didn't even know about. That's kind of cool. Um, this isn't a function. Anyone have an idea for a function that we could write that would have the same, that would connect with this equation? Yeah, right. Just replace that 0 with f of x. And this is what's called the related function. To that equation. Uh, and what could I do with an equation? I can't graph an equation, but what can I do with an equation? I can get the roots. I can solve it, right? I could solve this. The solutions to that equation, what would those be with respect to the related function? I hear it's like this info is entering one ear and leaving another. Totally understood. Fortunately, we've got it recorded, and I'm going to post this video so you can watch it over and over and enjoy the dulcet sounds of my soothing voice explaining this mathematics. Um, yeah, the roots or zeros of this function would be the solutions to the equation. So if I take the function and I find the graph of it and I find the x-intercepts, those would be the zeros of the function, which would be the solutions to the equation. And that's why it's called a related function. So let's do it. Let's graph it. We're going to graph it the same way. Actually, you know what? We're going to use the information that we have, negative b over 2a, to make it a little faster to graph and start with that. So b is negative 6. So I have negative 6 over 2 times 1, which is negative 6, or 6 over 2 is 3. So a lot of students will turn in to me the answer of 3 as your axis of symmetry. 3 is not the axis of symmetry, and I'd mark that wrong. X equals 3 is the axis of symmetry. And x equals 3 is not a number. X equals 3 is a line. And if we go to x equals 3, 1, 2, 3, we can draw a line. And I'm not, even though I really want to, I'm not going to use the crazy rainbow colored pencil because it caused massive lag last time. X equals 3. We have this line x equals 3. And we know that if we folded the universe, the right side and the left side along that green line should match up with each other. So when I'm making my table, what's a really important x value to plug in when I'm making this table here? 3 is a really good x value, right? This x value here, I'm going to plug in here because I want to find what point, when I plug 3 in, I'm going to get what point. Somebody say it or chat it or something. What's the point that I'm going to get when I plug 3 in? Starts with a V, ends with an X. Yes, thank you. The vertex. So I plug 3 in. 3, so I get 3 squared or 9. Whoa, weird 9. 9 minus 3 times 6 is 18. 9 minus 18 plus 3. 9 minus 18 is negative 9 plus 3 is negative 6. Negative 6. Negative 6 is the y coordinate of the vertex. 3 negative 6 is the vertex. Uh, what's another word for negative 6? Yes, the minimum. Thank you. So way down here, 3, negative 6. It's not letting me write on it because 1, 2, 3, 4, 5, 6, because it's on the pencil. Okay, so there's our vertex. Let's write that. And is it a parabola facing up or down? Up, because a is 1, which is a positive number. A is greater than 0. So we have a parabola facing up, and I can just sketch it. And I have no idea how much time we have left. We have 0 left. So we have no minutes left. So we have that picture, and we have a question what the x-intercepts are. And it's kind of a fun question to ask. What are the x-intercepts? They're somewhere in here. And you're going to see that the graph, it's going to be a little tough to figure them out, but we're out of time, so I have to stop talking. Thank you, everyone, for joining. Have an excellent day. I'm happy with what we got done in our 40-minute mini class today. See y'all. Bye. You too. There's a key command to stop recording. I don't know how to stop. What is the key command? It's 2 1 0 enter plus something like that -6. No, maybe if I stop sharing. Ah, there we go.